Hello and welcome back. In this video, I'm going to show you how to use multiple regressions to be able to reconstruct the SWE distribution, the snow water equivalent distribution across this study basin. So this is in the park range, and I've got the purple dots are the sort of fake pits that I've created for demo purposes. So what we're going to do is we're going to start by sampling. So use sample raster values. And in here we have our demo data. And the raster layer, we've got all of these that we want to sample. So we're going to build up that data set, remember. So I'm going to use elevation to start. And there you go. And then remember, as you do this, you're probably going to want to change the names. The next one you're going to make sure is sampled, and then I'm going to do fractional vegetation, which is trees. Okay, and just change that to S1. Okay, we're going to keep going here. So I've got S1, and the next thing I want to do is probably northness. Okay. S2, and lastly we'll sample one more and we will do the topographic prominence. How about that? That's TPI. Okay. Okay, once you have this built up, you can right click here, open attribute table, and we can see the points that we've collected. We've got the longitude and latitude. You've got the SWE that you measured there, the snow water equivalent. And you've got the attributes of each of the site locations. So if you right click, export, save feature as, choose comma separated value, that's CSV. I'm going to just save this as regression demo. And then importantly, make sure you change your coordinate reference system to that one that works with longitude and latitude. So that's 4326. Okay. Now that we've got that done and it's exported, I'm going to go over to Excel. This is Microsoft Excel, and I'm going to open. If you go to File, Open, I'm going to choose my that CSV I just created, that regression demo CSV. Go ahead and open it. And in here, you get a, you've just exported all of that here. So what you're going to do is, if you go to data up at the top, and then you go to data analysis, choose regression, press OK. You can choose the ranges. So your input Y range is going to be the SWE data that you collected. So that would be this one. The input X range is going to be all of the predictors. So in this case, this is those four that I've selected. Make sure labels is checked on so that it knows not to include the actual labels themselves. And your output range, I'm just going to select down here, and you can press OK. Okay, so what it's done is it's just fit lines through everything. It's essentially coming up with a slope in the same way that a, if you were to draw a plot and fit a slope to it. And those are these coefficients down here. So it's telling you the general relationship between a particular predictor and SWE. And the intercept obviously is that y-intercept. Okay, so I have rearranged my windows so I can see my coefficients and the intercept. In QGIS, we are going to now create a spatially continuous map that uses this model that we have just made. So I'm going to use raster calculator for this. I'm going to open this. I'm going to save this into my demo layers. Okay, and we're going to use the y equals mx plus b kind of format. So my intercept over here is this negative 0.08. So I'm going to copy that in. That's my plus b portion. And then I'm going to do the slope times the X value here. And so I'm going to start with the elevation and multiply it by its coefficient. Recall that I made this data up, so these coefficients are definitely not accurate. Then I'm going to do fedge and come over here and copy the fractional vegetation coefficient, and then add the next one will be the northness coefficient. Multiply it by this value from over here. And the last one will be that TPI one. Multiply it by this coefficient over here. Excellent. Okay, so what I've done is I've added in my statement here. It may look a little different for you because you might use more coefficients, more predictors that have more coefficients, and your coefficients will hopefully look a little better than mine because your data is not made up. But as soon as the OK is highlighted, it is a valid statement, so I'm going to run it. Okay, so I just got a spatially continuous map that followed the whole size of all of the rasters I've input. So we're just going to clip and go to clip raster by mask layer. So my mask, I'm clipping my regression map that I just made, and the Parker Range study area is that mask. Go ahead and run it. And I can turn off this one here, and you can see that we now have our study area working well. So I'm going to properties, and I'm going to check out what it looks like in the histogram. So you can see that the model thinks that sort of the most common depth is around 1.3, and it doesn't think that there are many values of snow deeper than 2 meters. When I zoom in to inspect what we've created, we can see our snow patterns generally follow topography, which is sort of what we would expect, given a generally pretty strong influence of elevation. You can see that it's at 50-meter resolution, which matches all of our input raster data sets. And when we look at it, we can see that particular pixel that I just highlighted has 1.4 meters of SWE. Recall that this data was made up, and so that's a huge amount of SWE comparative to this year. But it seems to generally work. I'd be interested to see how all of yours work. Okay, thank you so much.